Welcome to this module of Professor Messer's free Microsoft 7680 certification training course. This module is on configuring networking settings. I'm James Messer, and in this module, we're going to go through the requirements from our Configuring Microsoft Windows 7 exam in the Configuring Network Connectivity section. And a lot of this video will be about connecting up a network, being able to make sure that we see the network configuration, and working a lot with wireless networks and the way that they operate. There's also some Windows 7 features like location-aware printing that we'll also look at in this module. If you're plugging in or connecting to a network for the first time, there's some really nice wizards built into Windows 7 that can help you with that. Under your control panel, under Network and Sharing Center, there's an option to set up a connection or network. And in there, you can connect to the internet, you can set up a new network, manually connect to a wireless network. Here's a nice one, connect to a workplace. If your workplace has a VPN configuration, it's a nice wizard that steps you through the configuration settings. Or if you're still using a modem, there's a dial-up connection setting in there as well. There are other options under your Network and Sharing Center that you can use when you set up your network for the first time to turn on or off network discovery, which allows you to see other people on your network and allows people to see you. There is file and printer sharing you can configure if you'd like to make some files available or make your printer available for other people to use, and public folder sharing. You have a nice capability to enable a public folder that then anybody could connect to. They don't need a password to be able to see that, and you can make it a central drop point that everybody has access to. When you start working with wireless networks on our portable devices, then you're really working with 802.11 wireless. This is a standard that came from the IEEE. They standardized it so that everybody in the world could create hardware and access points and network cards that would all interoperate together. The four different kinds of wireless networking types you'll find are the 802.11a, the 802.11b, 802.11g, and 802.11n. As the names imply, as the numbers and letters increase, you're starting to see new versions come out. So I'll take you through the history of these. You'll get an understanding of what the differences are with the distances and the channels and the frequencies and a lot of the underlying technology of these wireless networking types. 802.11a was one of the very first 802.11 standards to be introduced in October of 1999. It's notable for operating in the 5 gigahertz range, which was a relatively high frequency, and it ran relatively fast too, 54 megabits per second, which on our networks that were wireless based, that was pretty fast to be able to do that. This has a smaller range than 802.11b. That's the operating range that we have for the wireless network. Because such a high frequency is in use, the items, the things that are in our way of that radio signal tend to absorb those particular frequencies very, very easily. So 802.11b, as you're about to find, had a lower frequency that it used, so it had a little bit farther range. It's really only useful then in some very specific cases. Some places where you'd go that was a normal workplace, you'd have a lot of walls, there'd be a lot of cubes, a lot of doorways. It's very, very difficult to get a lot of range out of 802.11a. But if you're in a warehouse where it's relatively open, you have a very, very high ceiling that you can use to put the access point, 802.11a worked very, very well. 802.11b came out at exactly the same time as 802.11a. And the reason there were two standards is that their technologies behind them allowed them to work a little bit differently. As I've already mentioned, 802.11b operated in the 2.4 gigahertz range, so about half the frequency that 802.11a was, but its speed was a lot less, 11 megabits per second. So a big difference there between A and B when they were first released. It had a little bit better range because you didn't have to deal with those absorption problems, but one of the challenges at the 2.4 gigahertz range was interference. Things like baby monitors and cordless phones and Bluetooth headsets all ran at 2.4 gigahertz. So if those ended up being close to each other, there'd be a lot of interference and your throughput would drop pretty badly. People who were putting up these 802.11b networks just had to do a little bit of extra work to make sure that wherever that access point was, that it wasn't conflicting with anything else that might already be out there. In June 2003, a newer version of 802.11b was introduced. This was 802.11g. The idea here was that it would operate in the 2.4 gigahertz range, just like 802.11b, but it would be much faster, 54 megabits per second, which was about the same as 802.11a, plus or minus a few administrative overhead capabilities there. This was backwards compatible with 802.11b though. So you could replace your 802.11b access point with an 802.11g access point, and yet all the people still running the B network could still communicate with it. So it made for an easy upgrade if you ever needed to get there, but it uses the same frequencies and therefore had some of the same challenges for managing the frequencies and the ability to throughput of the data if there were other things in place. So as long as you kept that in mind, then people usually had a pretty good job of having that 802.11b and 802.11g network work just fine. The latest standard from IEEE is the 802.11n networking type. It was standardized in 2009. It has the luxury of working at 5 gigahertz, 2.4 gigahertz, or both at the same time. So a lot of flexibility there. It also has extremely high throughput, 600 megabits per second in the best possible configuration. That's a lot of throughput for a wireless network, so you can start to see why 802.11n has become a lot more popular these days. This uses a technology called MIMO, which is multiple input, multiple output, has multiple antennas on it so that it can do that type of technology. The roll-up of all of these is right here on this slide. This is for A, B, G, and N. You can see the frequencies that are in use, the maximum theoretical throughput, and here's an approximate range that you'll often see when using these networking types. Wireless networks by design have a security concern. They are radios that are being broadcast, and anybody who's within earshot of those access points can hear everything that's going on. So we have two things that we need to think about from a security perspective. Number one, can you get access to the network? Are you allowed to connect to and participate on the network? And the second one is, can you encrypt that data so that even if somebody was listening, they wouldn't really be able to tell what they were hearing? The first step we'll look through are these security types of how we can have access to the network. There is an access type where you don't need authentication to the network. It's a wide open network and anybody can connect to it. Obviously, that's probably not one that you want to use, not even at home. You want to at least make it so that only the right people can connect to the network. There was an idea of doing this using just a simple passphrase, a shared key between the access point and the end station. You see this a lot in environments where it's something a little more casual, like your home office or the home network you might have. So we call that a personal type network. There are two different kinds of connections here called WPA. Another one's called WPA2. And as the name implies, WPA2 is a later version, a more recent version of WPA. WPA was one that came out between the times of WEP and WPA. WPA2 really is the one that you'll see almost everywhere these days. If you have a choice between them, you should always choose WPA2. In environments where you're in a large organization, there might be thousands of users on the wireless network, you might not want to use a shared passphrase. That's just too easy for somebody to be able to share with someone else outside the organization. So in those cases, there is a technology called WPA Enterprise or WPA2 Enterprise, which uses an authentication server. So you use your credentials to get onto the network and only your credentials. The next person coming onto the network has to use their specific credentials. It's not a shared passphrase. In some environments, it's very, very tight. You have to have a very specific certificate on your computer, or you have to have a smart card that you would slide into your computer to gain access. And in those cases, you would set up the security to be 802.1x. From an encryption perspective, you want to be sure that the data sent across the network is encrypted. One of the very first types of encryption is wired equivalent privacy, or WEP. One of the challenges with WEP, however, is that cryptographically it's very weak. There was a flaw found in the cryptography, and now WEP is really able to be encrypted or decrypted by anybody. WEP is not a very good way to encrypt your data. It's just too easy to hack. So the next version that came out was something called TKIP, Temporal Key Integrity Protocol. Instead of having this as a shared passphrase trays and everything is encrypted with the same configuration. TKIP changes all the time. Every packet is different in the way that it operates. And it was a pretty good method to use. There were some minor security concerns with it, and it was really meant to be something that would replace WEP, but wouldn't be the final encryption type. And indeed, with WPA2, usually the encryption type that you see is one called AES, which is Advanced Encryption Standard. That AES and WPA2 is almost always the method you will want to use unless you're using some really, really old technology on the network that can't use WPA2 and it can't use AES. And in those cases, you might have to fall back to a different version. But in almost every situation, you'll want to be sure that you've configured your access points for WPA2 using the AES encryption. You can connect to an access point and become a member of the wireless network using the Windows graphical interface. If you go to the control panel under Network and Sharing Center, you can connect to a network there, or you can simply click the icon that's in your system tray to connect to the network. You don't always have the graphical interface to choose from, so of course the netsh command is there for us. There's a netsh WLAN command that allows you to see the interfaces on your network, see the wireless networks that are available, and even connect to a wireless network all from the command line. From our Windows 7 workstation at the Start menu, let's go to our Control panel and go to our Networking and Sharing Center. And you can see everything that you might want to choose right here is related to the network configuration. Setting up a new network is right here. All of those wizards that we talked about earlier. We've also got the changes up here in the settings that we can use to connect and manage our wireless networks. And here's where we would connect to an existing network. I have a profile in here currently of my network, which means I can see that down here I'm connected to this wireless network. But what if I wasn't? Let's disconnect from this, and I'm actually going to remove this profile which says you can't connect to it anymore unless you create a new one. That's great. We'll do this from scratch. I can go right in here and either add it manually and create the network that way. But one of the easiest ways to do it is to go right down to the command line, right down here, the system tray rather, and click on the icon and choose the network you want to connect to and choose connect. And because there's not a profile there currently, it's going to give us a prompt to say, insert your security key right here. You would put in your security key and click OK. And it will now connect you to that wireless network and build a profile right there on the screen for us. So this means that next time, if I was to go back and disconnect from this wireless network and then reconnect, it simply uses the same profile. I don't have to type in my credentials every time to connect because I've already put in the correct security key. We can do all of this from the command line as well. Let's go back to the way we were. Let's disconnect from this network and let's remove this profile. And let's open up a command line option and do that same thing. I'll type CMD and get to the command line on our Windows 7 workstation. Now I'd like to use those netsh commands, and let's do WLAN and show interface there we go. And you can see on this computer, I have one interface. I have a Dell Wireless 1510 Wireless in WLAN mini card that is disconnected right now. So it's not really connected to the network. If I do a netsh and do a WLAN and show networks, I can see what networks might be available to me. This looks very similar to what we saw on the system tray. There's my local network, and there's a Netgear, a Linksys, and a D-Link that are all open. Nobody's really doing any encryption on there. What I'd like to do is now connect to this network, but I need a profile to be able to do that. And from the command line, it's not very easy to build out a profile. What I did was take a profile from another computer, and I saved it onto this computer. If you want to look at it, you can view this profile right here. It's an XML file. And as you can see, this is not something simple that you might be able to type in yourself. It would take a little bit of work to do that. But you can see in here that we do have the SSID, the types of connection, the encryption types, even your key is in here. So obviously on the screen you're looking at, you're not going to be able to see the key on this screen. I've blanked it out so that you can't see the key that I'm using on my wireless network. To be able to now connect to this network, I need to add that profile. So we're going to use the netsh command again, and I'm going to show the WLAN settings and add a profile and specify a file name, and my file name is going to be equal to that.xml. There we go. And now it says that that profile is added on the interface wireless. That's exactly where we need it. Now let's do a NetSH WLAN, and I would like to connect with the name of my profile that I just added. And I would like to specify the SSID that happens to be identical. There we go. And it says the connection request was completed successfully. Well, let's see what this looks like. Let's run that same command we ran before, which is WLAN show interfaces. And you can see now I am connected to that network. It even shows me how I'm connected, the method that I'm using, signal strengths and speeds as well. So a lot of the information we can get from the command line. In fact, maybe even a little bit more information from the command line that we saw over in the graphical user interface. It's a little bit more typing, but at least we have that capability if we are doing this management from another workstation. Whenever we set up a profile on our system, we're able to set different settings for that specific profile. You may be connecting to 1 or 2 or 10 or 100 different wireless networks depending on where you go with your laptop computer. So you may want to set certain profiles to have a higher priority than another. And you also might want to set it so that if you happen to be on one wireless network and a more preferred network comes along, you may want to automatically connect to that. Well, fortunately, you can set all of those settings from within the profile. From the Network and Sharing Center, if you click the Manage Wireless Networks, that's where your profiles are. I'm going to right mouse click on this profile and choose Properties. And you can see here's all of our settings. I can connect automatically when this network is in range, or maybe you don't want to have your computer connect automatically, and then connect to a more preferred network if it's available, which means we could be connected to this, but if we happen to get finally close enough to a preferred network, we're automatically going to switch over to it. And we can specify that this might be an access point, this particular profile might be an access point or a network that we'd like to leave if we happen to see that more preferred network. Notice you can also connect even if the network is not broadcasting its SSID, which may come in useful if you happen to be working with a lot of wireless networks that don't advertise themselves. You would set the priorities for these networks right here. You would have a list of all 10 of those networks or 100 that you connect to, and the priority is in this order. So you can move these access points up and down, these profiles up and down within this list, and be able to then decide which one has a higher priority than another. Our Network and Sharing Center also gives us easy access to the configuration of the network card and all of the settings within it. So if you need to get in there and configure some of the settings of the protocols or configure the hardware itself, you can find all of that in one place. From our Network and Sharing Center, I can click on Change Adapter Settings, and it's going to list out for us all of the adapters available. I can right mouse click on any of these and choose Properties and see all of the networking configurations in here and even the hardware configurations. If I click the Configure button, I'm going to get exactly the same hardware configuration settings that I get if I was working, for instance, at the device manager. So this is just another way to get that same information from here. So by using that single point going right to our Network and Sharing Center, I really have access to be able to get to any of those configuration settings. A new Windows 7 feature is one called Location-Aware Printing. This allows you to take your laptop to work, and your Windows 7 operating system knows that your laptop is at work, and it automatically sets up your default printer to be your printer at work. When you go home, you're on a different network. Your Windows 7 operating system recognizes you're on a different network, and it makes sure that your default printer at home is set for your home printer. That way you can move around and you don't have to think about it. You know that your printer is always going to be defaulting to the right place depending on where you happen to be at that time. We've been using the Network and Sharing Center for a lot of this, but for your printers, we're going to choose Devices and Printers. And it's going to bring up a list of all your devices and all your printers. And if you click on a printer, you'll see you have an option right here at the top to Manage Default Printers. And that's going to allow you to decide whether you want to use the same printer all the time or change the default printer when you change networks. And you'll see all the networks that you plug into and the printers that you've used for those. You can even add new ones if you happen to be on the Death Glider network. Maybe it is a Adobe PDF printer that you would like as the default. If you happen to be on the F302 network, maybe instead you would like to print to this Brother MFC printer. We'll add it into there. And now, no matter where you are, your Windows is automatically going to know what network you're on and set your printer accordingly. Let's review some of the things that we've learned in this video. Our first question, which command line option allows you to view the list of available wireless networks? If you recall, we listed those out at the command line using NetSH WLAN show interfaces. The next question, which wireless network type supports both 2.4 gigahertz and 5 gigahertz frequencies? Well, there was only one that did, and it was the 802.11n networking type. And our last question, you need to remove a wireless networking profile from a computer. Where can you find the list of profiles? Well, as you might remember, it is in your Network and Sharing Center, and if you choose Manage Wireless Networks, you'll see all of the profiles in there. That covers the requirements for our Configuring Networking Settings video. We've gone through wireless configurations, wired configurations, setting up your adapter cards, and even some Windows 7 specific features like your location-aware printing. If you'd like to watch any of our absolutely free Microsoft 7680 videos, you'd like to participate in our message boards, or you'd like to send me a message, you can visit our website at professormesser.com.